We are here at Kassow Robots in the Automatica, and Christian Kassow is here. Nice to meet you. You are the founder, and you want to show me your products here. I'm very satisfied about this robot.
Well, thank you for allowing me to do this. So what we show at Automatica this year, remember it's 4 years ago we were here last time.
Yeah.
So we are now displaying our full range of collaborative robots, 5 robot arms. We only had 2 last time we were here.
Yeah.
Then we also have some nice exhibitions from our sales partners.
Yeah.
For instance here, one of our sales partners has built a really nice AGV which automatically feeds a machine with those bobbins.
Yeah.
And you can see that the robot arm is actually sitting on the AGV, and it can travel up and down and those kind of things.
It's a lot of payload, isn't it?
It is, and it's an 18 kilo payload.
80 kilo. It's a cobot.
Yes, and it's still a cobot.
It's still a cobot.
Yeah.
Nice, yeah.
And
very compact.
actually, we also can do something quite nice with regards to reach. If you look over here, we have the longest reach arm. We have 1.8 meter reach it has. Then only 5
radius.
Yes. Then only 5 kilo payload.
It's
but
great,
still quite nice.
isn't it? Yeah. So we have 3 meters, 50, 60 around. It's impressive.
So it's almost like a crane.
Yeah.
So, and then of course also a new thing we are exhibiting this year is a demonstration model. So it's not yet for sale, but it's for basically a controller-less robot arm or controller cabinet-less robot arm. So it is targeted very much for applications like being sitting on an AGV, where you maybe only have 48 volt DC available from the battery. So it can run directly on battery, and you don't have a controller cabinet. That's the main feature with it.
So we have only a cable for the PLC, and that's all, and power, of course,
Exactly. So fewer parts with all the advanced and more compact solution.
How do you program it?
It's the same as our standard products. We have this, I think.
The teach pendant.
Exactly, the teach pendant.
We don't need an extra. Nice, I like it. I hope you will have a lot of success. Another European robot manufacturer.
Exactly.
Yeah.
That's what we are.
You are from Denmark. You're here in Munich, and I wish you very good success.
Thank you very much.
Thank you very much. We are here at Universal Robots. Universal said we have a big new thing to come here on Automatica, and here it is. It is a UR20. Now we know what Universal means big. With me is Andrea. Andrea, you're the general manager for Germany?
Yes, I'm general manager for Germany, also in Switzerland.
Yes.
And I'm hosting today the presentation of the big thing.
Yeah, of the big thing. Yeah. What is the thing of that big thing? Please tell me.
We are presenting today the UR20. So it's basically the step forward in our product portfolio. But it's not only a UR20 with 20 kilo payload, 1,750 millimeters reach, only 64 kilograms of weight. It is also the new generation of our cobot.
So the robot's weight is 64 kilograms.
Yes, it's only 64.
That reach and that payload.
Exactly.
And that's lightweight.
It is lightweight, and it is one of our most important topics that we can offer to our customers. So we wanted to keep that. We have much more speed in the joints. It is 65% joint speed. We have 25% more torque, and we have the very high performance. So we are convinced that it's not a step forward, but it's a jump forward for the cobot industry.
Okay. And you told me you have a new architecture inside the robot. It's the gears and...
Basically the joints are simplified. It's a complete new design that we developed during the last years. Again, we listen to the customers, we know what is important on the market, and we want now to deliver something extremely new. And the joint is basically the core of the new architecture.
Okay, so less parts, isn't it? Yeah.
Less parts is 50% of the parts that than on the E-Series. And yes, now we are really happy to show the results of the last years.
Okay, okay. And you told me that as a customer, if he has a training, he can change something, he can repair for itself. Yeah.
This is basically one of the main part of our UR Academy concept. So we are, let's say, many people talk about democratization of the industry of the robotics, or let's say do it yourself. Do it yourself is for the complete process. So we can teach the customers how to use the robot, but also how to service the robot. Of course, we have plenty of distributors and system integrators that can help, but we have all the option open.
Okay, that's really nice. Yeah, I like it, and all the UR Cups stuff is really great at UR. I think we talk about plug and work with a universal robot. That's great. New kinematics, isn't it? And on the older robots now, you change the kinematics with this technique. Are they like they are?
It's not automatic, let's say. Of course, what we learned, we already put also in the E-Series. In the last years, we are developing further also the E-Series. Here we will have something that is only for the new generation.
Okay, okay. That's great, yeah. I wish a lot of success. This helps the customers, the small-sized companies also to integrate robots. It's not only a cobot. Now you're going into an original industrial robot, isn't it?
Yes, well, we were always industrial robots, basically. And of course, there is the collaborative option if the application allows it. If you don't need a collaborative part, you can use it at full speed. And that's it. It's always tailor-made for the customer. The customer can decide how to use a robot. And this is the flexibility that we were talking about.
We need in the market.
Absolutely.
That's really great. Thank you, Andrea.
Thank you for your visit.
And have a nice time in Munich. You are living in Munich, isn't it?
But I'm still Italian, to be honest. But I love Munich, of course.
Yeah, of course. Most Italians do this. Thank you very much.
Thank you. Thank you for your visit.
Bye-bye.
Ready? Yes. And you? Me too.
So we are here at Franka Amica, a German startup from Munich, and you have a 7-axis robot, cobot. What is the special thing with Franka?
Well, what you see here is our Franka Production 3 series. So this is the new series that has been just announced 2 weeks ago on the HMI fair, and we are proud to present it to our local attendants here in Munich today. Yes, it's the new system. We have been in the market with our older Franka Amica robot system since 2016, but we are now launching this Franka Production 3 system with the focus for industrial production, as the name says. We also have a research line, the Franka Research 3, which is focused on real-time control and all of that, but this is really targeting industrial customers, industrial production.
Okay, okay. And on small, medium-sized companies can use it. It's easy to program, isn't it?
Exactly. So it is a 7-joint, 3 kilo, 855 millimeters sensitive cobot. We have torque sensors in all 7 joints, meaning that it is sensitive along the entire kinematic. So wherever the robot is being touched, it kind of feels it. We have that robotic sense of touch. And we are wanting to apply that tactile behavior, that dexterity, to use cases that can be solved otherwise, maybe with expensive equipment. We have camera integrations here, Roboception, also a Munich startup. But very often you can solve these use cases using that sense of touch in a simple and very often also more economic way. My personal way of testing if a use case is feasible with this system is closing my eyes and trying it with my hand. If I can solve it like that, you very, very likely can also solve it with the robot entirely.
Okay. Jonas, you told me it's very sensitive. Can I try it?
Of course.
We are now in automatic mode. If you start it, I can stop it. very easily?
Well, yes, you can. The robot has collision detection built in, you have these features. However, this is not like a safety feature, this is an application feature. So whenever you have we're talking about electronics manufacturing a lot, we have very sensitive parts, which we obviously don't want to destroy if there goes anything wrong.
So I put it. Okay.
Buttons, and then you can guide it around.
It's very easy. It's a big advantage, isn't it? Because of the 7 axis, isn't it?
Yeah, exactly. You can fold the robot and the entire arm whichever way you like it. You can position the arm, reach around things, and yeah, what you're feeling here, that very, very fast, sensitive feedback that you get on the arm, this is something that we do better than anyone here.
And we have some buttons here. I can program the robot instantly. Bam, 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 bam.
It is always like a hybrid way of your own device. So you can use a laptop, you can use technically your phone if you really want to. But when you're working with the robot, you don't always need to walk from the laptop to your robot and back. You can always do everything in here. So you can also control the entire interface. Here I can click around.
I just show it like employee and say, hey, do this, do that, and he's doing it all the day.
Exactly.
Yeah. That's really great. Made in Germany. It's safe. It's really safe. You have from TÜV Germany certificates.
Yeah, we are very proud to be the first robot that has achieved Fastsuite certification for 10 to 18 and 13.
Which is in Germany very hard to get.
The Fastsuite has a certain image in Germany, and they live up to that. And
you can be sure that it's safe.
And this is not just something that they did after we had built it. They were involved in the development of this product literally from the first screw that we put in that system. And we've gone through a lot of loops with them, and that was often very frustrating as well. But this is their job in a way. And now we are proud to say that this system complies with that, and it's not just us saying it, it's also TÜV that certifies it.
Fine. That's really good. So we have a lightweight robot, which is safe, which is very sensitive, very good sensitive. Is it cheap?
Is it cheap?
It's a 7 axis. Normally it's a 7 axis is 7 axis more.
It is still good value for money, I would say. But the pricing has changed a little to the old system, where we were very much focusing on having a very, very affordable
it's
hardware.
It's a price verse, isn't it?
Now we are changing the system a bit, and we say you pay an initial invest, which is also often a lot easier for industrial purchasing. Paying €1,000 every month to buy additional software is something that is still.
You have an app store. You can download. Whatever you need, it's already.
You can, but it doesn't work very well with industrial purchasing very often. So we are now having the initial invest a bit higher, but then everything that comes afterwards is very, very affordable. So at the end, the price has not.
The whole system, you only pay what you need.
The total cost of ownership to the old system has not really changed. It's just when is it being paid in a way.
So thank you very much, Jonas. Nice to meet you. I wish you a lot of success with this great robot. And I see you, I think, next time. I will hear more from you. Thank you very much. Yeah, bye-bye. If you want to program robots, we also need a software how to program it. And it's not too easy to program an arc welding robot. Here I have a cool product. It's Fastsuite from Cenit. And Jens Fetzer is with me. Hi.
Nice
and you show me the new feature from Fastsuite. Yeah. How is it working?
We have a lot of new features, but one is a very interesting thing here that I'm going to show you briefly. So arc welding is definitely one of the most crucial robot applications. Defining complete robot operations and welding operations is extremely simple now by just indicating a few points. We automatically, just 2 points, we automatically analyze the workpiece. We define the complete operation, and we can also indicate touch sense operations just with a few mouse clicks. After confirming, we can immediately verify the result.
I see now it's calculating and touch sensing and welding.
The robot motions, all controller commands are generated. We can automatically download it to the robot cell and can start the execution.
That's like it has to work. Yeah.
Exactly.
Easy robot programming, and it's CAD data, everything. Yeah, and you can do this in Fastsuite. But not only arc welding, but what else?
Well, we do have a lot of applications, 3D laser cutting, where we have another feature, by the way, it's an automatic collision avoidance that we have implemented here.
Right, yeah.
Drilling, riveting operations, we have surface treatment operations, sanding, painting, deburring, whatever you need. Everything, every robot application that requires offline programming, we might have a solution for you.
And Fastsuite is a tool which not only generates the motions, but also arc welding on, off, and all the application stuff you need in the robot program too.
Exactly. Our approach is to deliver a turnkey solution that enables the user to easily operate complex robots with no further touch-up on the robot cell later on.
That's great, yeah. Have a lot of success in Automatica, yeah.
Thank you.
And thanks for sharing us your nice product, yeah.
In case your visitors want to learn more, fastsuite.com is the website to go.
Okay, visit fastsuite.com.
Exactly.
Bye-bye.
Thanks.
Here I am at Siemens in the Automatica, and Siemens has a new tool. This is the Robotics library, yeah?
Almost, yeah.
You tell me the right name?
Semantic Robot Library.
Semantic Robot Library, okay.
Yeah.
And the idea is you have one teach panel, one controller for different robot manufacturers. Amit, welcome at Robotics Channel. Please tell us, what is that? Yeah.
Thank you. The Semantic Robot Library, as the name already suggests, is a library that enables us as a TIA portal user to program, to commission, and to operate different robots using only TIA portal and only PLC logic.
Okay, but I have a teach panel too, to program the robot, but it's programmed in TIA portal.
Yes, so the panel is basically a part of the TIA portal project, and you can make the teaching in the panel, and if you need any extra programming, you can do that in the TIA portal.
Okay.
Yeah.
That's fine.
So for the operator, for the normal, regular operator, it wouldn't matter if it is a KUKA robot or a Staubli robot, it will have the same interface and they will have the same philosophy, same knowledge required.
Okay, okay. You have many robot manufacturers on board, most are cooperating with Siemens, not all. Some time before, some manufacturer tried that, what Siemens reached now, to bring all robot manufacturers, nearly all manufacturers in one hand, and you control as Siemens, a KUKA, ABB, Kassow robot, and as most as possible, of course. Yeah. And it's easier for the customer to integrate a robot. Not only have to expert knowledge of every robot, you only need one. This is from Siemens, and you can program all. Yeah, that's great.
Yeah, I agree. Especially for customers who already have a Siemens equipment, who already have Siemens know-how. It's the perfect match. Yeah. Also for customers who are machine builders, who are not only limited to one robot manufacturers but multiple. So yeah, that's good for them too.
Yeah. Okay. That's nice. Thank you. I mean,
thank you very much.
Left a lot of success with that project. I agree. That's really great. Yeah. Thank you.
Thank you very much.
Okay. Another cool thing from Siemens I saw here, and Martin will explain me. This is an AI camera, which is easy to use for the integrator, isn't it?
Yes, what we actually show is a piece picking software running here on our new device, which is very lean and easy to use. And what it actually does is to enable robots to pick any object.
Here are any objects like different stuff, and the AI here's a camera, will detect where to grip, where to suck, whatever. And I don't need any new knowledge about AI. Exactly. That's my problem. I don't actually know what that is. Yeah, it's smarter than me. I heard. Yeah, but I don't know how to handle it. And Siemens, especially your product. What's the name of?
This is our TMMFP, technology module multifunctional platform.
Okay.
And it's more or less an IPC. So you can run this software on our IPC.
Yeah.
And that enables automation engineers to set up such system. So that means you don't have to be an AI expert. That makes it really easy.
Yeah. So you have a wizard to
Exactly. We have a nice wizard to set up the system, to calibrate the robot arm to the camera and so on, to your whole system, and also to integrate it to your existing automation system.
Okay, that's great. Yeah. Thank you very much, Martin.
Thank you.
Have a lot of success. I like the system. Yeah. Okay. Thank you. Here I am at Visual Components. Visual Components is a software which is a general, how can I say, simulation software, planning tool, but I can say a lot. Humor, it just can help me to introduce your great product. Hi, welcome to Robotics Channel. Yeah.
Excited to be here. Right, so Visual Components is manufacturing simulation software. So from robot simulation to factory simulation to cell level simulation, you can all can be done in Visual Components. Yeah. So if we think about the use cases of Visual Components, we have here in 4 screens multiple use cases or the way Visual Components can be used. So if
start with concept.
Yeah, if we start from visualizing the concepts, so Visual Components is a great tool to visualize the concepts because we have the workflow is like super easy to use. We have
I can see it.
Yes, we have VR connection and VR glasses as well. You can use those. But the best thing about Visual Components, I would say, is that it's very easy to use. It's all plug and play. We have more than 2,500 ECAD components in our catalog, so you can just.
So you can have a table, have a robot net, and whatever,
Exactly.
A drilling tool, whatever,
Exactly. So whether you want conveyors, robots, grippers, machines, you can just easily drag and drop from the ECAD to the 3D world.
Okay, I see a lot of robots here,
Yeah, we have about more than 1,600 robots from 60 different robot brands.
Yeah.
So you can just drag and drop them in the 3D workspace, plug and play them together, and that's how easy it is to set up.
You can make
the
a concept how it works.
Yes.
And then I go into the production planning,
Yeah, so once the concepts are done or the layout is set up, I think it's important to kind of define the simulation behavior. So we have a feature called process modeling where you can define the products, processes, and flows. So any component that you've added into the 3D workspace can be defined as a product. Then we have processes defined to each of these components. So if there's a machine, there's always a process defined to it. When door opens, there's machining done, for example. And then the door closes.
The program needs a brake and all this stuff you can integrate there.
Yeah, they are predefined, but if you want to change them, it's also easy to do. So custom processes can also be defined. Here you can see product assemblies that can be defined. But for example, once the processes are defined, so here you can see an example of process that the machine is idle, then machine starts the process, then there are cycle times.
Okay.
And then you start to define the flows. So you start to understand how the product will flow from point A to point B, what will be the logic, and it's all visual. So that way it's very easy to understand, not just for the one who is designing, but for the one.
I can also understand complex flow charts, from beginning, where get material to the ready product, isn't it?
Absolutely. So whether it's simple process or complicated, it's just very easy to see and understand, not just for the one who's defining it, but also for the whole team who's working on a layout.
Okay.
It can be easily shared, and then people can see, oh, this is the flow, this is how it works. So if they want to change it, it can be easily done.
Okay. And I can check this before I have it in real here, in reality, and I can see, I need to optimize that, and it saves a lot of time and money, of course.
Exactly. So before you allocate any cost to the physical systems, it's always good. That's why simulation is there. So you want to check everything virtually first before investing in your production setups.
Okay. And then?
So if we move on to once the production flows are defined, now it's time to kind of analyze the whole simulation behavior and understand if it's actually optimized or not. And then you start to optimize things. So if you look at this buffer here, you can see that the buffer fill rate was it's improved from 60% to 82% with just changing the height of it. So these are very minor, from minor to major things you can easily start to check with simulation studies. You can see how many AGVs you would need for your setup, if 4 are enough or you would need 5. If there are any queues, then you know that, okay, we add another one. Then you start to see the utilization, has it increased or not. So in order to have utilization of your assets, it's important to use simulation studies for that. And if we move on to robotics part, we have, as I said, we have so many robots, so you can check the workspace, you can see the reachability of the robots, you can see the collision detection as well. So here you see they highlight in yellow when they collide. So those are the things that you can easily...
You can optimize then, where is the robot's best place and all this stuff.
Exactly, so you can check the motion paths and everything with visual components that way. And optimize it.
And if this all is done, we want to see how it's running, isn't it? And that's your last step?
Yeah, so the last step is virtual commissioning part. So what is best about visual components in a way is that once you've done your simulation studies, you can it's not just a standalone system on a screen, but you can actually export the programs to the hardware part.
So it's already all done, my motion planning, my workflow and everything. And they can generate robot programs, PLC programs, and all this stuff in one thing.
So whatever you have in software, you start to then transfer it to the hardware and connect both of them together. That's what stands out in visual components. And then here, for example, you can see path statements being defined. And then once you program the robots, you can export these robots programs to the actual controllers. We have free-to-use post-processors, but we have also Fanuc robot connectivity, Stowley robot connectivity, universal
so you can
robots.
directly control the robot.
Exactly.
Or you can generate robot programs which are put in by USB stick.
Right, so you can connect it to the robot controllers. And then one of the interesting things that we have upcoming is a new feature called KUKA OLP solution. So it's going to be in Visual Components 4.5, and with that is you can program the KUKA robots in their native language inside Visual Components.
Okay,
so
that's cool.
That is incredible. And then what's really best about it is that you don't really need to have this file exports and imports and so on. You can directly connect from Visual Components to KUKA virtual and physical controllers. And that really saves a lot of time when you are commissioning the solutions.
You have an original KUKA robot controller inside the simulation.
Exactly.
So that's nice.
That is incredible. So it really saves a lot of time with virtual commissioning, testing, validation of robot programs. Then you bring in PLC connections, so you can actually test the whole layout and see the functionality of it. And then you can change things, and then you can transfer it into the real world.
Really nice. Thank you for sharing us how visual components work. I like it. I wish you a lot of success in automatica and in the future. Thank you very much.
Thank you. So, it was pleasure to meet you, and this was fun.
Okay, subscribe to the channel and give the video a thumbs up. See you in the next video. Stop.